We're going to be looking at network troubleshooting. Network troubleshooting is certainly a large topic because there are lots of different things that you could encounter. It's kind of a difficult topic because it's one of those where, at every step of the way you could branch off into different directions. But we're going to try to cover it as completely as possible in comparison with the objectives of this version of the exam. Now we'll start with troubleshooting methodology, and that's very important. Having a plan, having a structured approach to trying to troubleshoot problems, regardless of the problem, can end up benefiting you in the long run. It helps to make sure that we don't miss things, and it helps to ensure efficient troubleshooting and mainly resolution of problems. Also important is knowing the tools that you have at your disposal, and this is going to include both software tools as well as hardware tools. Now, most of us in daily life as networking technicians probably won't deal with the hardware stuff at quite as much, and we need the software tools to be able to troubleshoot connectivity issues. But the hardware is important as well when we start to have device failures or things like that. And then finally, we'll just go through troubleshooting network issues. It's going to be a number of different categories, different types of problems as we work through and talk about potential solutions for those problems. In this first topic, we're going to look at the troubleshooting methodology, a structured framework to troubleshooting that can help us to be more efficient in problem resolution. Let's start with an introduction to troubleshooting. Troubleshooting attempts to determine the root cause and the solution to problems, and we should be doing so by applying a logical, consistent method, which is also known as a troubleshooting methodology. There are some specific keys to effective troubleshooting, and number one is choose a troubleshooting model. There are troubleshooting models that are out there that are different. It doesn't really necessarily matter which one you choose, so long as you choose one, right? And you kind of stick to it and you use that methodical approach to problem solving. In addition to that, you need to learn as much as you can about the systems and technologies that you're supporting. So, kind of as we go through this, you probably are going to encounter things that you're not that familiar with, and that's okay because we're learning this. We're going based on these objectives, and I'm telling you, when we get into the actual problems, it's a wide range of physical and logical types of issues, many of which we won't encounter depending on our role in the company. But regardless of that, once you get into a position, learn as much about the systems and the software that you're supporting. That's going to assist you a great deal. Other keys, just keep calm and be professional. Sometimes users are frantic when they're having a problem because their daily workflow is being affected. They may direct some of that frustration and even anger to you. Believe me, I know. We have to try to keep calm, be professional, get them talking in a way that is helpful to us, as in giving us information, guide the conversation, but to do so with a cool head. All of those are keys to effective troubleshooting, but as I said, we're going to get in and focus on that troubleshooting methodology. So the very first step in troubleshooting methodology is to identify the problem. The first step to efficiently identifying and resolving issues is to clearly identify the problem. You can't fix a problem if you don't know exactly what it is. And so that involves gathering information from various sources. Okay, so we have multiple things that are a part of identifying the issue. And the first is just information gathering. And that's going to be open-ended questions to identify symptoms and problems. What I mean by an open-ended question is we're really not trying to ask yes or no questions. Initially, we're trying to get the user talking to describe the issue to us. Having said that, sometimes users will describe an issue, but you have to remember they don't understand all the technologies that are at work. So there are going to be times where you do have to ask pointed yes or no questions just to clarify something that the user just said. Okay, because we do have to consider that users don't know exactly how to answer. They don't know. We can ask these leading questions, but they don't know what we're getting at. So we need to keep that in mind and always remember to be specific, when necessary. So initially, why don't you describe this issue to me? Then I might ask a couple of clarifying questions that are yes/no responses, or I might, take you a step further in what you're describing, etc. You also need to consider that all errors will not be reported. Different or depending on the actual problem. Users may not think of an error. Users may not tell you purposely about something if they think it was something that they did wrong that they're trying to hide. Okay, so we have to consider that. If at all possible, it's great to be able to duplicate the problem and see it yourself, because if I can see it myself, then I'm not really going based off of their description anymore. Instead, I'm able to actually reproduce this. I also know it's not a one and done problem at that point. I mean, some problems will rectify themselves automagically, is the term that I like to use. That does happen. But see if we can reproduce the problem and see if we can do so consistently. Identifying the symptoms, what exactly is happening. Determining if anything has changed. Ask the user, what, if anything has changed, when was this, the key question I always ask is, this is something that you have previously been able to do, correct? We're trying to identify if this is something new that they're attempting or a new way to attempt something, and so we want to ask them if they've done it before, and if they've done it before, then has anything to their knowledge changed since the last time they were successful at performing this operation? Now, we do need to, again, consider that they may not tell you, especially if they think that something they have done has caused this and that they might be in trouble for that. Again, this is just real life. So the other thing you could do is try to determine changes on your own. I work for an MSP. I think I've said that a couple of times. We have a ticketing system. So when service tickets come in for problems, they're assigned to a technician, but they're recorded, and I can look it up by company. I can look it up by a ticket number. I can see notes that other people have put in there. We can see if right now there might be a project that's going on for this company that's related to this problem. So that's a way in real life every day that I would go and try to determine changes on my own. All right, see if there's any reference in our ticketing system to other issues. All right. If there are multiple problems, try to always approach them individually. Certainly, in some cases, problems are related to one another. Okay. So, for instance, right now I've got a service ticket with a client, and he's complaining of multiple things in relation to email. So the Outlook client frequently disconnects and asks for the password. The out of office information is out of office can't be used, can't be set, and calendar sharing sometimes is sporadic. There is definitely the possibility, in fact, it's highly likely, that those three things are all related to one another. And so I could attack all three, but instead what I did is I said, okay, I think these are all related to one another. And if I can solve the problem of the Outlook client connecting to the email server, then I probably will also resolve the others. But even if I don't, I still have resolved at least one out of the three. Okay. So again, my point is there are definitely things that are going to be related to one another when we get into network troubleshooting, but we need to try to be careful to isolate and resolve issues one at a time. So once you've identified or gathered information about the problem, the next step is to utilize the symptoms as well as your knowledge of the system and technologies to establish a theory of probable cause. Okay, what do we think is causing this issue? Okay, and you can certainly question the obvious. By that I mean, don't just assume. I have to do this all the time. I have to remind myself, don't assume that because a setting is some way by default that it's that way now, because somebody could have gone in and changed it. At some point in the past, somebody could be a part of a project that requires a change of that particular setting. So just because it was working yesterday and it's not working today doesn't mean that, those default options aren't changed. So question the obvious, check the obvious. Examine the individual parts All right, let's talk about a network connectivity to a issue to a particular website. Well, you've got your own IP configuration, you've got your default gateway, you've got your DNS server and DNS cache. All of those are individual parts to that equation to get to the web server. And additionally, the web server is potentially a problem as well. You can create a list of the most common reasons why an error might occur. And then we can kind of establish what we think the most probable cause is. Now, and there's different approaches here, top to bottom, bottom to top. When we use that terminology, we're really kind of talking about the OSI layer. So bottom to top would be checking physical connections first, then checking IP configuration, then checking application layer protocols, and finally the destination. Okay, or you could go top to bottom, which is just the reverse. Divide and conquer is essentially, okay, we're just going to lay out all of the different components, all the individual parts, the possible causes, and we're just going to hit one at a time until we hopefully find a resolution to the issue. Now, once you have a theory, you need to test the theory to confirm the cause of the issue. If confirmed, you move on to creating a plan of action, but if not confirmed, you go back to the drawing board. So the next step is to establish a plan of action. All right, I think this is the issue, and this might involve research. It is possible that you don't know everything about every piece of your network. That's certainly the case for all of us, and it's certainly the case if you work for like an MSP and you're providing support for other companies, right? Frequently, we get a service ticket that tells us, okay, this is the problem, not the specific cause, but this is the problem. We establish what we think a probable cause is, but then I have to go and do a little research on their network to know where all these pieces are. You know, email servers, DNS servers, domain controllers, web servers, particular applications, things like that. So that can take research in those scenarios. And there's other cases where you might just encounter a problem that you've never seen before, you know, and so I'm doing a little hunting on the internet, and I'm looking for potential fixes based on these error messages, based on these symptoms. You should always understand the possible effects of what you're doing. Okay, make sure to research well and make sure to know where you're getting your information from, right? Getting information from a Microsoft support article, an official Microsoft support article, is far different than getting your information from a support forum, where individual users are just responding to one another to try to help solve problems. I'm not saying anybody is going to, purposely mislead you, but it's possible. It's possible that they're not purposely misleading you, but what they're suggesting is not really a good idea. So we want to understand the possible effects, and then we want to use our knowledge of the system to determine the most likely plan of action. When we put it all together, we want to implement the solution. As you implement a solution, you should remember to always implement one fix at a time. I've frequently forgotten it myself, and so it's easy for me to remind you, but harder for me to remember myself. Just do one thing at a time. Don't go in and make 3-4 changes to the system only to find out that your problem is resolved, but you really don't know which of those 4 things worked. Okay, so we typically are going to implement a change. If that change didn't resolve the problem, then we should revert that change. Okay, now there are some exceptions to that. I could implement a change and I move past the first error and I'm now presented with a second error. Well, if I reverse that change, then I'm going to be back to where I started. All right, so there are some times where there are multiple steps that are necessary for you to fully resolve a problem. If you find yourself in a situation where you're way out of your comfort zone, or this involves a technology that requires third-party support, or this requires higher level engineers within the company, well, then we escalate. We don't have to fix every problem. Most companies will have escalation procedures that we can follow. When we're done, we need to verify full system functionality. We need to try to identify preventative measures. If the user, in fact, was, somewhat quasi-responsible for what happened, then we can identify where they could have done something different. And then the key is certainly documenting documenting what we found, what actions we took, and what the outcomes were. Now, this has certainly helped a great deal if you have a help desk ticketing type of system. In our company, we use one called ConnectWise, which is a pretty common one out in the industry. It helps because we have to document. It forces it. I can't close a ticket without putting in some notes about what I did. And when I close a ticket, it notifies the point of contact that I closed the ticket. So if I just closed it without solving it, well, then they're going to come back and say, no, you didn't. So that certainly assisted a great deal through ticketing systems, and larger organizations will have that. Smaller organizations, though, this is still important. Even if it's just you and a couple other people that work for your company in the IT department, it's very important to document. In fact, it might even be more important in those scenarios because you don't have this ticketing system to fall back on. And so having some form of documentation will greatly assist you for future problems. And we need to communicate with the end user to make sure they're satisfied with the result. We need to communicate with the end user to make sure that they know what they could have done differently, if that's required, or just to at least explain, okay, here's why this happened, and here's what we did to fix it. And as always, remember to be professional and have a good attitude, regardless of the attitude of the individual that you're helping, and realize that can be a bit difficult at times, but just keep it in perspective. They're not mad at you. They're just frustrated at technology a lot of times. They're frustrated that they don't know how to fix it. They're frustrated that they have to wait and their workflow is interrupted. Try to be respectful of that and just be professional. In this topic, we'll be looking at troubleshooting tools, both software and hardware tools that can assist you as a network technician in troubleshooting common problems. We'll start with hardware troubleshooting tools, and depending on your exact job within your company, you may not have a whole lot of experience or need to deal with hardware tools. Okay. Having said that, it's still important for us to understand the hardware troubleshooting tools that are available to us, because some of us might find situations where we have to utilize that. Here are some, and some of them are kind of self-explanatory: screwdrivers, needle nose pliers, tweezers. A 3-prong grabber can be used if you've dropped something basically within a system. Small flashlight, anti-static bags, containers for holding screws, grounding wrist straps. That's kind of like your generic hardware troubleshooting toolkit. There are additional network tools that can be helpful in addition to these standard hardware components. So a network toolkit should include a number of things. One is a multimeter. Multimeter has the ability to measure voltage, current, and ohms or resistance. Multimeters can be used to determine whether or not a cable is, the wires in a cable are complete from end to end. Okay, so you can measure for resistance, for instance, and you would be able to determine if there was a break in that cable. A cable stripper and crimper, the fourth or the fifth one down there, those are going to be used to actually make cables. All right, if we've got unshielded twisted pair, we still have that plastic sheathing around the physical wires inside the UTP cable. So you have to strip that back, and then you use a crimper to attach an RJ45 connector. Not necessarily from a troubleshooting perspective, unless you suspect the cable might be bad, or you can visibly see that the connector is not right and you want to redo that connector. Snips would just be a cutter. That's just the ability to cut the wire. A punch down tool would be used to attach the network cable from a workstation drop to the back of a patch panel. Wire maps are going to be useful as you try to, essentially map the path that a wire takes or should take if we do have to run cable. We've got a couple of TDRs, time domain reflectometer, and then optical time domain reflectometer. Those can measure latency issues on cables. So you have copper cables would be your TDR, and then your OTDR would be fiber cables. We've got the cable certifier. Cable certifier is an actual handheld machine like what we see here, and it is used to certify the throughput and connectivity that's available on a cable. The fusion splicer is the next one, and that's on the objectives, but unless you're dealing with fiber, you won't deal with a fusion splicer. It's basically a machine that's used to weld or fuse two optical fibers together. Okay, the fiber ends are prepared, they're cleaved, they're placed in an alignment fixture on that fusion splicer, and then put together. A tone generator is actually used to locate cables. What you'll find is going into the wiring closets, you usually have huge bundles of cables, so it's difficult to tell which cable you're trying to deal with. So a tone generator along with a tone locator are used to basically send a signal down that can be detected by the tone locator, usually the same component, send a signal down that wire to be able to identify the particular wire in a bundle of wires. And then a spectrum analyzer is more of a wireless thing, looking at the wireless spectrum, the available channels, trying to identify overlapping channels, things of that nature. So again, as you can see, I mean, these are physical tools. If you're, in daily life as a network technician, you may not have to deal with this. I don't have to deal with these because I don't deal with a lot of physical issues. A lot of our issues are logical, they're configuration, they're routing, switching issues, things like that. But it's certainly possible for us to have physical related problems, and that's where these tools will come in handy. As a part of your software toolkits, there are a number of additional tools that we can use. Wi-Fi Analyzer is a program that you can put on a mobile device or tablet or laptop. It's going to give you more than just the signal strength. It's going to show you SSIDs. It can show you overlaps. These are used for site surveys, but they can also be used to troubleshoot signal issues as it relates to wireless. Packet capture, protocol analyzers. We've mentioned these a couple of times. Ethereal, Wireshark are a couple of the most common freeware versions that are out there. You can download these and then you can capture packets to and from your system in order to troubleshoot connectivity issues, encryption issues, those kinds of things. Bandwidth speed testers, these are usually available online. They allow you to test your bandwidth. This is sometimes necessary. Well, especially if you're trying to copy large amounts of data, like upload it. Some network connection types, some ISPs will throttle your connection. I've had several situations where I was trying to upload massive amounts of data to the Azure cloud or to SharePoint Online, and the connection would work fine for about an hour and then it would get throttled. Well, we used the bandwidth speed testers to identify that yes, in fact, it was being throttled because the ISP was claiming that they weren't doing it, but we could clearly show the evidence that it was happening. A port scanner, like there's one called Angry IP Scanner. I don't know why it's called Angry, but it will it'll scan a destination network and it'll look for systems that are advertising open ports. That can be used just to locate things like a VMware host or something, or a firewall, but it can also be used to evaluate the ports that are open. iPerf is a software tool that's used for network performance measurement, just think performance, as well as tuning. It's a cross-platform tool and it can produce standardized performance measurements for pretty much any network. It has both client and server functionality, so it can create data streams to measure the throughput between two ends in either one or both directions. NetFlow Analyzer is actually a specific tool that's deployed to perform monitoring, troubleshooting, as well as in-depth inspection and interpretation of traffic flow data. Analyzing NetFlow facilitates more accurate capacity planning, and it makes sure that resources are used appropriately in support of organizational goals. Now, it is not, I say it's a specific tool, but there are multiple options for that. So they, if you go and look, you'll find several. Some are freeware, some cost money that allow you to do NetFlow analysis. A terminal emulator is a program like PuTTY that you would use to connect into routers and switches. Of course, the old Telnet client was a terminal emulator as well, but PuTTY supports SSH, so you can connect directly into a router or switch to be able to manage it or to troubleshoot it. An IP scanner and port scanner are usually synonymous. I mean, IP scanner is just looking for IP addresses, whereas IP scanner is just looking for IP addresses, whereas a port scanner will also identify open ports. But again, typically they're one and the same. Now, in addition to those types of tools, you have a bunch of operating system troubleshooting tools, and a lot of network problems are related to incorrect configurations either on the local machine or other network devices, and they require these troubleshooting tools that focus on logical networking and focus on on protocols. So there's various TCP/IP troubleshooting utilities. Unlike some of these others that you may never actually use, these are going to be available on multiple platforms, and they are going to be very useful for you. So ipconfig and the Linux Apple variant ifconfig are used to validate the configuration of a client machine. Netstat is used to view open connections, the ports you're listening on, as well as executables that are listening on those ports. Ping and traceroute will use ICMP, the ICMP protocol. Ping just to see if you can get a response from a destination system. TraceRT to trace the route to that destination system. NSLOOKUP is a DNS name resolution tool. NBTstat, corresponding NetBIOS name resolution tool. That one's not overly used that often anymore. ARP is to look at your ARP cache. We've got other commands that are used to view the configuration on a router or switch. And then we've got some other tools that I didn't include in here, but we're going to take a look at in a demonstration. In this demonstration, we're going to be looking at using TCP/IP troubleshooting tools and some other software troubleshooting tools. As I've mentioned, this is going to be stuff that's very important to you, practically speaking, really on a daily basis. Okay, now, not all of them, depending on the operating system that you're utilizing, but the vast majority of us will be using these, pretty much every day. So we're going to start with some of the basics, and then we'll also talk about some of the other ones. I'm just going to open up the terminal. You can open up a command prompt depending on what operating system you are using. Probably the most basic would just be your ipconfig. Okay, ipconfig showing you your IP configuration, your IP address, your subnet mask, your default gateway, your way off your local network segment. Remember, as we talked about before, the subnet mask needs to match so that the default gateway is actually on the same network segment as you are on. Otherwise, that is going to cause connectivity problems with anybody on remote subnets. ipconfig/all will show you a bit more information. Okay, there you can see your host name, your DNS suffix, whether DHCP is enabled, your MAC address, DHCP server, your DNS servers, etc. Okay, so you would be able to see those things as well. ipconfig display DNS. ipconfig display DNS is going to show your DNS client cache. Those are the recently resolved names and the IP addresses that they were resolved to. ipconfig flush DNS, and I believe this should all be review, is going to flush or clear the DNS cache. And when we were talking about that in an earlier chapter, we also looked at PowerShell equivalents, get DNS client cache and clear DNS client cache. But the test is more than likely going to ask you about the others. ipconfig register DNS would be to register DNS records. And that's pretty much it for ipconfig. Okay, but ipconfig is a good utility because it allows you to just validate that configuration information. It is ifconfig in the Linux operating system, but it's going to operate in a very, very similar fashion. Okay, then we have ping. Now ping, you utilize another IP address and you attempt to ping that IP address. Okay, it's going to send ICMP echo request packets and hope to get echo replies. That really just means that the system is up and running, but I believe we've mentioned before, the caution that you need to have is that just because a remote system doesn't respond doesn't necessarily mean that it's not there, because ICMP has some vulnerabilities. It's an older protocol and a lot of firewalls will block it. So if you can't ping one address, try to ping another. You generally speaking should be able to ping your gateway. You should always be able to ping DNS servers. And you should be able to ping a lot of servers out on the internet, just not all. Okay. And so, oh, that's right, my DNS server's down. So anyway, if you get something like this, it means that your ping request couldn't find, like you couldn't do name resolution. If you get something like request timed out, it could be just an ICMP issue, or it could be a firewall issue on that remote system, or it legitimately could be that you can't communicate with them because they are actually down. All right, if you get a reply, they are up and running. So those are kind of the things you're looking for. There are parameters to ping-a. If you have an address, you want to try to resolve it to a host name. That's a useful one. Ping-t will do a continuous ping. That can be useful if you're trying to troubleshoot routing issues. And then we have force it to use IPv4, force it to use IPv6. You don't have to memorize all of these. I'm just saying you can always go ping / and you'll see the different options that you've got. Similar to that is going to be traceroute, traceRT. The difference is that traceRT tries to trace the path that a packet takes. And I apologize, we're going to have to switch machines for this one because traceroute never works in the cloud. So let's switch over to my local machine. Okay, so now we're on my local machine, and I'm going to go ahead and do a traceroute. Okay, here we are actually going to see my router responding. ICMP is pretty locked down in the cloud. Let's try this again, because I'm going to use a switch that tells it not to do DNS name resolution. There we go. So that has a tendency to go quicker, because what it's trying to do is actually resolve the names at every hop. At some point, traceroute may stop, but what this does show me, in other words, stop responding, because it is based on ICMP as well. What this does actually show me, though, is that my packets are getting off of my local network segment. So this is useful for tracing the route that a packet will take to get from the source to the destination. And that can be very handy, because I see there were a couple routers there in the middle that didn't respond, or at least didn't respond fast enough, but I still was able to get to that remote location. And so really the key is past the first hop or two. You're just trying to make sure that you actually got off your local network segment, that your router knew what to do with it. Now that's spelled out to the full traceroute in the Linux operating system, or just traceRT in Windows. All right, the next one in the list is the ARP cache, or the ARP utility. If you just type in ARP, it's going to ask you for parameters. So ARP-A will show you cached entries in your ARP table. These are typically dynamic, although they can be static as well. The dynamic entries these are systems that you have tried to communicate with on your local network, and the MAC addresses that are associated with them. So it's not like the DNS cache that can have all kinds of stuff in it. This is all going to be local addresses. Just so you know, my IP address now on this one is 192.168.254. That's my local network. And so when we go ARP-A, we're going to see that those local network addresses. That's my router. This is the broadcast address, and then these are who knows what other systems on my my network that we've been communicating with, or I have communicated with at some point. The ARP cache is not really like the DNS cache, in that there's not really timeouts. So it is going to cache the fact that this IP address matched this MAC address. You really don't need to mess with the ARP cache that much, but if you did need to, it would be to delete a host. If there were invalid entries in the ARP cache, you would want to get rid of them. Or if you want to add a static entry, you can add an IP address to MAC address mapping. Okay, next one, Netstat. I believe we've looked at this. Netstat shows active connections on the local system. You got Netstat. I know we already did look at it. Netstat-A, and it shows active connections. Netstat-B would, along with A, would show you the program, the executable that was actually involved. And so this is going to show any sort of connections and what the foreign addresses are if I'm in a listening state. And this is interesting because a lot of times you can identify programs and services that are running on the system that maybe you didn't know were there. Netstat-A is kind of the way to do that. Okay, now just so you are not confused, new name is just the random name that I gave this laptop. But it's showing port numbers that I'm listening on. Okay, so and then as I said, that stat -a and -b would show the actual executables. That one you have to do from an administrative command prompt, but I know we saw that in a previous demonstration. Okay, a couple that are name resolution related. NSLOOKUP. NSLOOKUP, you can just type in NSLOOKUP and it'll ping your default server, and then you can just make multiple requests. www.google.com and it'll ask that. www.yahoo.com and it'll ask that. mail.fccp.coop, it'll ask that. Okay, so you just get answers. It's showing you the server that you asked, and then the non-authoritative answer. Non-authoritative answer means that it went out and got that information for you. It didn't have it on its own. You can also just do NSLOOKUP and then type in an actual name, and it'll just look up that name as opposed to go into the interactive prompt. But NSLOOKUP in the interactive prompt does allow you to do a number of things, requesting particular types of records. That's probably the most common one for you to do would be a query type, setting it to a particular type A record, MX records for this particular domain. Stuff like that. Okay, so ls-t mx ssc.coop, for instance, and it should list out the MX records for that particular domain. I think earlier in the course I showed you an MX toolbox website, which is kind of nicer than this probably, but essentially that command will do the same thing. Not exactly sure why it's taking that long to execute, but there we go. Oh, no, maybe not. Okay, just didn't like the domain. Sometimes with the list commands, you do get some errors just in the way it's trying to interact. But the command itself was accurate. Just happened to be with the domain I was using. Okay, so NSLOOKUP, a dig, DIG is the Linux equivalent to that. Hostname is another one that they have listed. Hostname simply shows me the name of my computer. I don't know how useful that is, but I take that back. I've used it on many occasions just to check the name of a system. I've had users open up a command prompt and type that in to tell me the name of their system. Next one is route. Okay, route, you need some sort of argument. Route print is probably the best one. I believe we looked at this before. Shows me the routing table. Okay, so we won't go through that again. Telnet, if you have the Telnet client. If you don't, Windows machines will not have the Telnet client by default. Okay, it is something that can be quickly installed. It is useful from a troubleshooting standpoint. It's a quick way to connect into other systems on a particular port to try to troubleshoot that port. So I'm going to go into PowerShell. This is not the only way to install Telnet. We're going to go install Windows feature. Give it a second to catch up there. Okay, so install Windows feature Telnet client. Oh, maybe not. That's the easiest way to do it on a server. And I apologize. Like I said, it's the easiest way to do it on a server, and I'm used to working with servers, so we'll do it the other way. Running PowerShell as an administrator, I'll use the DISM utility here to enable a feature that's not enabled. You can also just use Control Panel. I don't know that this is much easier, but that'll go through and install it. Now, obviously, you only have to do that once. Once the Telnet client is installed, then you're able to use Telnet to get into remote ports. And just so you know, there's a PowerShell equivalent to this testnet connection with the port parameter that I'll show you that is clearly easier than actually having to install the Telnet client. But that doesn't give you all of the same capabilities, specifically with email, and maybe I'm biased because I do a lot with email. So specifically with email, using the Telnet client gives you just more capabilities to interact with the server as opposed to just, is it listening on that particular port? All right, so now that that has completed successfully, we can actually go Telnet and then plug in, say, a remote system, port 25. Okay, and what it'll try to do then is try to first resolve the name and then try to connect into port 25 on that system. And it looks like maybe I should choose a different system here. That's the second time I've tried to use that one, and it's not resolving, or something's not right. Just in case we go back to looking at that just to make sure, like, is that the actual problem? Because you could always use an IP address if you're trying to get to a remote system. So telnet, IP address, port number. Okay, and then it makes an attempt to connect to that system. In this case, it actually appears like that system may not be responding, maybe having a problem. So we'll try a different one. I'll just hit Control C because I would like you to see this. And it's possible, the firewalls are blocking. Maybe the firewall's only allowing connectivity from, a particular location or something. Port 25 is generally open, but I mean that's still always a possibility. So how about telnet SMTP office365.com port 25? And maybe I'm just having a problem with all of these, and the telnet is not functioning to get into those ports. Maybe this is actually on my end. I'm not sure. But this is what you're going to get if you can't connect. Okay, if you can connect, you should get a banner identifying the mail server in this case, or just identifying the system that is responding, that it's listening on that port. So anyway, that's what telnet's really used for today. I mean, again, it can be used for remote administration, but because it doesn't support encryption, you don't really want to use it. You don't want to use it that way. And this appears to have totally just kind of hosed my system there. There we go. Okay. With PowerShell, you do have test net connection. They're probably not going to ask you about this on the test, but this is an easy way just to see if a remote system is listening on a particular port. Okay. So test net connection, the name of the system, then the port parameter, and then the value of whatever port. And so what it'll do is it'll try to do that connection, and this one appears to not be working either. So I don't know what it is about port 25, but something about my local machine here, I'm unable to get to a couple of these servers on a port that I thought that was going to be open. Okay. If it's unsuccessful, it'll sit here waiting for a response until it finally times out. If it is successful, it will come back and tell you that the port test was successful, along with doing a ping test. So testnet connection is going to do a ping test, and then if you add the port parameter, it's going to do a port test. There were two more that were on the exam objectives. I'm not going to show them because they're not built in, but these are freely downloaded and work across multiple operating systems. So TCP dump is a network packet analyzer. It's just one that runs in a command line interface. So most people prefer Ethereal or Wireshark. Nmap is a utility that is open source, but it pretty much... Oh no, I take that back. It runs on both Linux and Unix and Windows as well. It was originally a Unix-only tool, but there's a Windows version now. That's a network scanner that's used to discover hosts and services on the network by basically sending packets and analyzing responses. So TCP dump is a packet capture software. Nmap is a port scanner, IP scanner. Both of those have to be downloaded. Okay, we're still waiting for a response on this, and we'll just kind of let it go. Again, I'm not sure what the timeout problem is with trying to connect to these port numbers, but regardless, we still see the purpose of Telnet, and we've looked at a number of other TCP/IP and software troubleshooting utilities that as a network technician you can use to identify and resolve issues. In this topic, we're going to be looking at troubleshooting network issues. I will say this is a somewhat difficult topic just because there's so many ways, so many directions you can go with some of these problems, and some of these problems aren't overly common on today's networks, but yet they are in the objectives. So we're going to do our best. If there's a question about any of these things, I would just recommend, doing a little research on the internet to get some indicators as to reasons why you might suspect a particular issue is the problem, and then the potential resolutions. So we're going to start with wireless problems. It's the first of the list of objectives on the exam. And wireless networks are obviously using radio signals and transmitters, and they encounter problems that do not exist on cabled networks. And the problems are possible in multiple areas. We can have actual hardware problems like a physical NIC, a physical access point. We can have signal-related problems like interference, environmental factors, attenuation and loss, distance, etc. Security problems such as encryption mismatches, the wrong passphrases, the wrong SSID, and then just configuration problems. So the problems that exist in those areas, and remember we talked about troubleshooting methodology, it's important that you kind of focus in to see what, number one, what all the different pieces in the connection are, and then you seek to eliminate those pieces from being the problem cause. So let's start with signal issues. There are various potential sources that exist. So the first thing you should do if you suspect a signal issue is to try to identify the strength of your signal and attempt to remedy that situation. Okay, and we can do this just through the little, bars indicator in a Windows operating system. You don't need a Wi-Fi analyzer, although more persistent problems may involve the use of additional tools. Okay, keep in mind there are several things that can affect the signal in a wireless network. Okay, number one is environmental factors, and I think we mentioned this before when we were talking about wireless standards, and I said that in some homes a single access point will suffice because of the size of the home and the construction of the home. In other homes or businesses that are larger, then there are going to be other environmental factors. Cement walls, for instance, actually have an effect on radio frequencies going through them. Okay, so I've found that older houses, multi-storied older houses, or multi-storied older business buildings can suffer from signal degradation that doesn't exist in other places. So keep in mind the environmental factors. Interference of other electrical equipment, certainly interference of other wireless access points, wireless networks. That's something that you definitely want to consider. Overlapping channels can cause a problem. So if we are in densely populated areas where there are a lot of wireless access points, going in and adjusting the channels, as we saw was done on my access point, can help to try to get around these signal problems. You just have general attenuation and signal loss. Now those are basically synonyms to one another. Attenuation is the degradation of a signal over a certain distance. Okay, in wired networks, we don't have a lot of other factors that can cause heightened attenuation. In wireless networks, you have these environmental factors, interference, etc., that can just cause signal loss. Sometimes you're connected, sometimes you're not. The next one's pretty specific. RSSI stands for Received Signal Strength Indicator. It's an estimated measurement of how well a device can hear, detect, and receive signals from an access point or Wi-Fi router. An RSI closer to 0 is stronger, closer to -100 is weaker. Okay, you would only be able to determine this with a Wi-Fi analyzer, and obviously for the best performance you want your RSSI to be as high as possible. Another pretty particular one is the EIRP. This stands for Effective Isotropic Radiated Power. Okay, what does that actually translate into? Well, basically it's the power of the antennas. And the later standards have higher powered antennas because they use the MIMO technologies, whereas legacy access points just use a single radio chain. And so most of the time, obviously the later the standard, the better it's going to be. But you can potentially manipulate the transmit power of a wireless access point, again, if this is a more persistent issue. You kind of have to decide, like, is this a persistent issue? Is this an issue that affects everybody, or are we just talking about individuals? Obviously, if at all possible, just move closer to the wireless access point. If you can move closer to the wireless access point and that fixes the signal problem, then you may just be in a situation where you need to use wireless extenders or add additional access points. We also have the potential for hardware and configuration issues. Okay, hardware, obviously wireless communications requires physical components. Those physical components can encounter problems that could include antennas, the placement of the antenna, the type of antenna. So we discussed that. We're talking about site surveys. We need to make sure that signal issues aren't just due to the wrong antenna. And if it's consistent across multiple systems in a particular area, then that's likely. Maybe we need a different type. We need a more directional antenna. Or we could adjust the polarization of the antenna. There's also configuration issues, channel utilization, as well as client disassociation issues. Now, the channel utilization goes back to the planning and needing to make sure that we're utilizing the proper channels on the access point and the client. The disassociation, those are very specific error messages. Client could be disassociated due to inactivity. If it's not heard from for 5 minutes, it's just gone to sleep. It could be de-authenticated, okay, whereas it, maybe it passed from one access point to another. Or it could be disassociated for some unknown reason. In other words, it's just no longer communicating with the AP, but it failed to notify the access point that it should be dropped from the association table. Now, that last one is typically associated with wireless interference, but technically can be caused by any issue that would cause a client to suddenly stop being heard by the access point. Some of our issues may be wireless security issues because, as we've discussed, wireless LANs utilize additional protocols and standards to make sure that the connection is secure. The wrong SSID is a common problem. This would be troubleshooting typically an individual computer that's having trouble connecting via wireless technologies. Make sure they're connecting to the right SSID. I've seen this countless times where people thought they were connected to the Wi-Fi, quote unquote, and they really don't have any, they're not understanding that one Wi-Fi is not the same as the other Wi-Fi. We have to be connected to a particular access point, or maybe I got accidentally connected to the guest network, and that's not giving me file and folder access to servers. Incorrect passphrases, that one, of course, would cause your inability to connect just initially. It's clearly a problem, but one that should be easily remedied. Encryption mismatch, that's going to be a little bit more difficult, but that's typically with older access clients or older access points. If they don't match, you and I don't support the same level of encryption, then we're going to have an issue. And then sometimes we have captive portal issues. We discussed that being a screen where you have to provide some additional level of authentication. If I don't provide that authentication, then I'm not going to be able to connect. If it doesn't match whatever it's looking for, like last name and room number in a hotel, I'm not going to be able to connect. I will say this, sometimes the local firewalls on a laptop or tablet will prevent the captive portal from opening up. This can be remedied by disabling the firewall temporarily, rebooting the machine and trying to reconnect to the access point, and possibly even changing your default browser. Especially if your default browser is an older browser like Internet Explorer, well, then changing it to Edge or Chrome, Firefox, something like that, often will remedy that situation. Okay, so we've gone through wireless connectivity issues. There are also a number of potential issues that can arise on wired networks. Typically, these specific problems are problems within the cables themselves. So we still have attenuation. We still have distance limitations on wired networks, that if a cable has to run, cable drop is too long between the client and the switch, that can cause the degradation of the signal. You can have interference as well. It would be more with electrical equipment where following the wire runs, but that is a possibility. And in some cases, if it's persistent enough, we might need to go with shielded twisted pair. Incorrect pinouts, that's probably an individual problem. That would be incorrectly wiring the RJ45 connector. All right, so if those wires aren't lined up with the TIA 568A, 568B standard, then that would be a problem. A bad port on a switch, that's certainly possible. Bad port on a NIC, or I would just add a bad cable. Okay, now that's probably opens and shorts. The open or short is the same thing, really. You have a break in the cable. Now, that could be within the cable itself. A lot of times, it's due to improperly crimping the RJ45 connector on the cable, or it could be on the back of the patch panel as well. And then duplexing issues. This typically wouldn't involve a client not being able to communicate, but instead would cause a client or server to not communicate at the level to which you think it should communicate. So if, for instance, you're supposed to be using full duplexing and you're only using half, then you're not going to be getting those the advantage of that extra bandwidth. So we need to make sure in that case that both the NIC and the switch port have full duplexing turned on. TXRX stands for transmit and receive. If the transmit and receive are reversed, that's another indication of just bad wiring. Typically that would only result, or that would only happen if we'd actually made our own cables. Some other common cable issues, specifications and limitations, throughput, speed, distance. The distance is pretty much the same for all copper, but the throughput and the speed will not be the same. You have to look at all the different pieces. You have to look at the NIC. It needs to be certified for a particular Ethernet implementation. These days that should be gigabit or above. But if you have older NICs that are only fast Ethernet, well then they're only going to transmit at 100 megabits per second. The throughput could be based on what just the activity and the utilization of that network card. So you can kind of take a look at that as well. Cable considerations, we said shielded versus unshielded. So if you're having common problems with wire runs, attenuation, signal loss, drop packets, those kinds of things, it might be time to look into shielded twisted pair as opposed to unshielded. And you also need special rated cable if it's going to be running through the HVAC runs. Okay, it's called plenum cable. It has like a Teflon coating. It's more resistant to interference. It's also more resistant to fire. Could just be a problem with the cable itself. Okay, there are different kinds of cables. There's a straight through cable. There is the crossover cable. A crossover cable is not going to work between a network device and a network client, but would work between two network devices themselves and would sometimes be required, especially for older equipment that can't do that transmit receive translation itself. The cable that you use to connect to a switch or a router is called a rollover or a console cable. It's not the same thing as either crossover or straight through. So point being, don't always assume it's something really involved. It could just be a cable. And it's a good idea to try to isolate the cause of the problem by just switching cables. We could also have issues where we have a cable that's not rated for power over Ethernet, so it's not actually supplying power to the device. That could be another potential cause. There are a lot of potential network issues that don't stem from hardware problems, but instead are logical issues, configuration issues. So invalid IP configuration. And actually, let me stop and say that a lot of these are probably the more common. Yeah, sure, we can have physical issues with cables, but in the vast majority of the cases, we're just talking about some sort of logical problem. So if a client doesn't have a valid IP configuration, they're not going to be able to communicate on the network. Now that might be they have a 169.254 address, which is automatically generated because they couldn't reach a DHCP server, or the DHCP server didn't have any addresses to give. But if you do an IP config on the client and you see that, if you see 169.254, you know immediately where to troubleshoot. If you see an IP configuration that just doesn't match the subnet that they're on, then that could, then it needs to just be reconfigured. It may have been statically configured and done so incorrect. An invalid default gateway will always have the same result. The client will be able to communicate on the local network segment, but would not be able to communicate to the internet or to remote subnets, and that's because the default gateway is my way off of my local network segment. So ipconfig is going to show you that. Remember when we talked about subnetting, that default gateway always has to be on the same network segment. It's possible we have missing routes. This would be more likely on a router itself than it would on an individual client, just because we don't manually update the routes on clients. Routers may have been given bad information from other routers or had static routes misconfigured or just not be there at all. And then the symptom of that is you would be unable to reach remote subnets. A duplicate IP is always going to cause a problem. Now, in a lot of cases, the machine that is already using the IP will continue to function. The system that tried to use the duplicate IP will be listed as 0.0.0.0, and so that's kind of your indication of that. We mentioned speed duplex mismatch already, but that's just making sure that those are equal when it comes to switch ports and NICs. Incorrect VLAN assignment would be very similar to invalid IP configuration. You'd be able to communicate with systems you weren't supposed to be able to communicate with, but not with the ones you are. And so that's something to look at on the switch port. Misconfigured DNS or DHCP. DNS specifically can result in you not being able to resolve names correctly. I've had many times where somebody went in and assigned a public DNS server to clients on a Windows network. That's all well and good for internet access, but it prevents those clients from being able to communicate with domain controllers. So the clients, we said this when we talked about DNS, the clients should always be obtaining a DNS server that's internal in a scenario where you have a domain, because I need all that internal name resolution to happen without going out to the internet, and my DNS server is capable of forwarding traffic out to the internet to find answers to questions that it does not have. Simultaneous wired and wireless connections, that's kind of a simple one. It happens sometimes, and it does typically cause communication problems. NIC teaming misconfiguration, that would be more of a server issue. Interface errors, you typically have to go in and do performance monitoring, network monitoring, or switch monitoring. And then MTU misconfiguration, that's the maximum transmission unit. That's kind of an oddball, but it's still out there. Often it's on voice networks or SAN networks that you need to increase that value. So I'd say those last three are not as common for client computers, but still can exist and something that I want to be aware of. Now, due to all the security measures in place, today's networks can encounter misconfigurations in security that can cause problems to network communications. We just saw this when I enabled IPsec in a demo, and it immediately terminated my RDP connection because a firewall is used to prevent communications, or in this case, to enforce additional authentication and encryption. And if it's misconfigured, which I inadvertently did, then it can prevent communication. So always check the firewalls. If you're not being able to communicate in a way that you think you should, one of the first things to check from a security standpoint would be the firewalls or routers. Routers are not as expansive as a firewall in the protection that they provide, but they do use access control lists, and those ACLs can be used to prevent traffic. It's possible that a port is just closed. Okay, if you're trying to communicate with a server via HTTP, port 80 needs to be open. Via SMTP, port 25 needs to be open. We can use the Telnet client to connect to a particular port. Now, I know we've said don't use Telnet, but just from a troubleshooting perspective, you can use Telnet to make sure that you can actually communicate with that system on a particular port. The PowerShell version is test net connection. Could be denial of service. A system just could be down or under attack. Could be result of unpatched firmware and operating system. So you can look at those types of things when you're dealing with security issues as well. In this chapter, we looked at network troubleshooting. We started with a troubleshooting methodology, a structured approach to troubleshooting to help us efficiently identify and resolve problems. We discussed that the actual methodology is not as important as you just using one. Using one to make it so that I don't miss things and so that I can isolate and really resolve these things quickly. We talked about troubleshooting tools, both hardware as well as software troubleshooting tools that are available to you. And then we looked through a number of different common network issues and how it's some of the possible causes and probable resolutions for those issues. Well, this concludes the video course for CompTIA's Network Plus, the latest version, the N10008 exam. In this course, we started with network fundamentals, just giving you kind of some general networking 101, talking about the different components that are required in order to connect to a network, the purpose and functionality that they provide. We looked at the OSI reference model and how it defines exactly how network communication happens from source to destination. And we looked at various topologies and network types. Then we looked at network communications. You need a NIC, you need a protocol, and you need cabling or wireless connectivity. So we talked about the common cabling and connectors that are available to us, common ports and protocols that make up the TCP/IP protocol suite, along with application layer protocols. And then finally, IP addressing, how to assign IP addresses and the functionality of the IP address as it relates to network communication. Then we looked at network infrastructure. We started with just general network devices that are used on every network, switches and routers being the most common in the modern network. Talked about some of the configuration and capabilities of those devices, as well as other networking devices that are available to us. And then finally, data center architecture, where we looked at the layout of enterprise networks. In the next chapter, we looked at network implementations, so network services like DHCP and DNS and the functionality that they provide. We talked about wireless standards and technologies and the unique nature of wireless communications, the different standards that are present for Wi-Fi, and different security options you have as well. We then looked at remote access, remote control using RDP, remote node using virtual private networks, and the various components that are included in that. And then we finally looked at virtualization and cloud concepts. In the next chapter, we looked at network operations, so organizational documents and policies that define the kind of a structured approach to networking, acceptable use policies, password policies, change management plans, etc. Then we talked about the importance of availability, high availability and disaster recovery, and the various components that we could put in place to ensure that within the organization's network. In the next chapter, we looked at network security. We started with some security fundamentals, looking at the fundamental goals of confidentiality, integrity, and availability, and how those are achieved. Concepts like cryptography, digital signatures, hashing algorithms, and encryption. We looked at how to identify threats and vulnerabilities and use those to assess risk within the organization. And we talked about some common threats and vulnerabilities that exist for all organizations. And finally looked at the security controls that you could put in place to protect your organization's network. In the final chapter, we looked at network troubleshooting, and we started with a methodology, a structured framework towards troubleshooting on the network to help us efficiently identify and resolve problems. We then looked at various hardware and software tools that you have at your disposal that will assist you in troubleshooting these issues. And finally, just several different categories of potential problems that you might encounter on the network and possible resolutions for those problems. So as I said, that completes this course designed to help you prepare for and pass the CompTIA Network Plus N10008 exam. Once again, my name is Patrick Lohner. It's been my pleasure to be your instructor on this course, and we'll see you next time.